Hopefully Renzo is gonna watch the record. Who knows? Okay. So as I'm saying, we are in the second class. This is week 5. So this is week 5, right? Yeah, week 5. But we are still in week 4 topics. As you know, in first class I don't teach. That's why we are always this way. Like week 4, class 2 we are in. Okay. But technically it's week 5, lecture 1. So don't get confused with that. Bottom line, we are in the second class of the plotting. Okay, we started in last class the plotting. Okay, what did you do in plotting in last class as a nutshell? So we did like the basic plotting of x and y. Before we even did that, we had to define the x and y array matrix, right? Matrix. You guys remember the matrix? We had week 3 matrix, right? So we use those x and y matrix to draw a plot, right, in a figure. I say like this is your figure 1, right? And then what? Then we learn how to put the axis titles like x-axis, y-axis, like x level, y level. That's how they define that, right? We learn how to put the title. You remember that? We learn how to change those title or level info in terms of the font type, font thickness, bold, all sorts of things, right? Line type. We learn how to change the line type under the plot. We learn line type means like the dashed line or the solid line. We learn how to change the thickness of the line. We learn how to change the color of the line. Everybody remember that? We not only that, we also learn how to change the font size of the axis marker. Remember? So like you had this, you use this GCA. Remember GCA, and said there was a function for that GCA. Everybody remember that? Okay. So once we are done with all those things, right, we learn how to draw multiple plot in the same figure by using this command. What is that command called? Anybody remember? What is that command called if you'd like to draw multiple plot in the same figure? Hold on. Yes, that is the hold on. So you learned the hold on. Jason, you remember the hold on? Okay, so once you have multiple plots in the same figure, then we started to learn the subplot. Anybody remember the subplot? The subplot is a function where we had like this number, the column number, row number, column number, and the placement, right? We did use the subplot in so many different ways, right? Remember, we had the matrix like 2 by 1, means like 2 row 1. That's the first thing we did. And then we had this matrix 2 1 1 for the first one, and the second one we had these two figures, right? So then we used like for the second one 2 comma 2 comma 3 for the third location, 2 comma 2 comma 4 for the fourth location, right? So one figure on the top, two figures at the bottom. That's kind of unique. We learned that, right? And while we were doing that, we also used the hold on function, if you remember that, right? In one of the subplot, we had multiple plot in that one. Remember the hold on function that we used? So last class was pretty informative and probably one of the most important class in this programming, because plotting is something you would be doing all the time. The same thing is true for the matrix chapter, like week 3 topic. Matrix is something that we'll be doing all the time. Any question? Okay, what is the agenda for today's class? As I said, today we don't have that much. I mean, you guys should be master on the plotting now, okay? And that means we're gonna do some exercise, right? I don't have that many. I have like probably 2 or 3. We're gonna be able to finish it probably in 30 minutes or so. And after that, my expectation was, as I was saying, I'm saying the same thing on the record. I was saying, like, usually in the second class on any topic, my expectation from you is you started doing the homework and the practice so you can ask me question, I can address any of your concern, right? So after the exercise, that we will have plenty of time, we can deal with that, okay? Like as if like in today's class, from my understanding, nobody started the homework, right? The homework number 4 or the practice number 4. That means most likely you don't have any question or concern. So the class will gonna end way early. But from next week on, for the next topic, okay, my expectation is like that, okay? In the second class, you want to address questions if you have any. Not necessarily you will have any with the homework or the practice, okay? Is it clear to everyone? Should I move on? So again, figure, we're gonna deal with the figures and the practice of some of the figures, okay? It's on record, perfect. And then let me go to my class note. So as you know, we always start with the title and the title description. So this is week 5, lecture 1, right? And we're gonna do plotting. The way you can write it is uh, without a space. You can put a underscore, right? So plotting examples. And it doesn't really matter what you put in the comment space. No space doesn't matter, but still it's a good practice to put a name like with underscore. And then the title description, right? So you are dealing with more of the example, right, of plotting in Octave. Okay, and you can put your name, and then the date, I guess, or email. I mean, the other things, whatever you want to do. And then I'll just simply jump into the main code. And these are the thing. I'm not holding too much here because I know every day you are doing the same thing, like CLC, clear and close all. Then you want to do the first example. So this is the example number 1. So you are doing the plotting, the temperature data. Okay, so problem statement. So you want to plot the average daily high and low temperature for Canton, New York. Everyone can see that? Does it need to be a little bigger or it's fine? The font size is okay? Perfect. Okay, so then after this, you'd like to start with the givens. The givens are the temperature data. Temperature data. So what is the temperature data? You want to first define a variable called average high. Okay, and then you want to specify those manually. By the way, usually you can get those info, this kind of temperature info, from Excel file, CSV file. So you'd like to import those files, but for now we'll just simply manually put those data. So you will have these 26, 29, 39, 53, 66, 75, 79, 78, 70, 58, 45, 32. So these are your temperature data. So you can type it average. So average daily high, right? High temp. So the next one would be average low. So average low, you want to make sure the variable name needs to be kind of corresponds to what the data you are putting. So another trick here would be like, average high, average low, A and L or A and H needs to be in cap. The others needs to be in lowercase. So the average low temperature would be 5.7. Now here's other way you can do. You can put a comma as well if you remember, or the space does the same thing, right? Because remember, those are multiple columns, but I'm not doing it. Just like to highlight that. Okay. So 5.7, 19, 32, 45, 54. So 54, 58, 40, 48, sorry, 56, 48, 37, 28, 14. Missing something. So I'm missing a data. There should be a 58. Make sure you have like 12 and 12. Okay. If you don't matches the, if you don't have the matches data like average high and low, it will not gonna work. Okay. The indices will not gonna match. You can try it. It will not gonna run. So then you're gonna put it like, okay, after the semicolon. Anybody remember what is this semicolon is for? Hide it, right? You don't have to display it in the command window, right? It's there, but it's not showing. So it's the average. So average daily low temp. All right. So you'd like to now, like, remember there are like 12 data points, right? And those are corresponding to every month, like month January to December. So you'd like to define those months, right? So these are the temperature. So temperature in Canton, New York by month. Okay, so you have a new variable called select months, right? Where you can define it 1 through 12. Now, if you remember, you can skip that 1 in the middle after the first colon. And then you can simply type, this is the array of months from 1 to 12. Now what? You'd like to create a plot. So you are creating a plot. So figure 1. So you're creating a plot here with this month and average high. That's the first plot. And then you're going to use the hold on and you're going to do the month and average low is the second plot. So in the same figure, you should have 2 plots. Okay. I'm just holding myself here a little bit just to make sure everybody is with me in terms of the typing. Once everybody's done, let me know so I can move on. Okay. Yeah.
For the increment method of putting down the matrix for months, do we not have to put brackets?
No, we don't. We don't need to put bracket or anything. So this matrix can be defined this way. Like one thing that I was showing, remember that middle one, like after 1 there's a colon and 1, that's the increment, right? You can skip that. If it's the increment of 1, you can skip that. If the default is 1. If the increment is different than 1, then you should definitely put it in the middle one. Otherwise, it will not gonna work. You're gonna just simply go with the increment 1. Any questions so far? Everybody's done with the typing? Can deal with the plot now? All right, let's do this. Okay. So we do have these two plots in one figure, right? Figure 1 I defined already. So you want to deal with the plot first. So the plot, and then you would like to start typing. Oh, I'm sorry. Yep. So I have the month, right? And then I'm gonna first do the average height. So average height. I start whenever. Excuse me. Oh, sorry. Whenever you start to type the average A, capital A, B, or something, immediately it will gonna show up. You choose that and enter. Okay. So that'll gonna save you the time of typing the whole variable. Everybody see that, right? And the other benefit would be the chances of error is less. If you start to type by yourself, there is a big chance that you're going to do the mistake. You understand? All right. So not probably here. After you're probably writing hundreds of lines in a programming, then definitely yes. So that should be a practice that you should be doing. Okay. So the other thing in last class that we learned. Okay. Remember the marker. If you'd like to choose a marker, say like O, you're gonna choose this one, and then say like you'd like to. You can do so many things. Line width. This is one of the things that you wanna do. Who knows? And then 2. Now remember, there's another thing that we learned in last class. So line width, first of all, if you'd like to change, I mean, just like other things like the font, remember the font size, font type, all those things we change, right? So anytime we have a change, we have to make sure we write that character. This is a character line width, right? We write that character under single quote. Do you see the single quote, single comma, inverted comma, right? Single quote. It needs to be in this single quote. The character can't be exposed without a single quote. MATLAB Octave can't read it. So it must needs to be single quote. Anytime you have a character, anytime you have a numeric number like 2 here, you don't have to do that because MATLAB Octave understand this, right? This makes sense. And the other trick must needs to be remembered. Line with N and line with L and W. The initial of both words for line width needs to be capital. Not only that, both needs to have no space in between. That the same thing is true for line size, line, and everything. You know what I'm saying? You remember all those things that I said. Okay, so then your plotting is done. Okay, you can save it and exactly see it like how things are. So week 5 lecture 2, right? Let me. So spring 2026. Oh, this is week 5 lecture 1. I'm sorry. See how time passed? We are in week 5 now. All right, so run it. See if you have a figure. Oh, we do have a figure showed up. Does it show up similarly for everyone? With the marker? Oh. Raise your hand if it doesn't. Figure F small. Starting now? So what do you want to do next, everyone? You're gonna do the hold on, right, option, and the months and the average low, right? That's the thing you wanna do. Same plot in the different plot in the same figure, right? So you're gonna start typing here say the next line, right? So hold on, and then you wanna plot it again. I'm gonna copy it. So average low. All right, and then the second one, I would like to create a OR, means the red line, right? The marker needs to be red. Line with 2, I'm going to keep it as it is. I'll save it. I'll run it. See, I should have this now. The same circle, but it needs to be red because the R I put after the O, that's what we're going to make it red. See, we do have these points here. Make sure whenever you have experimental data, you'd like to display it in a point, not a continuous line. When you want to use the continuous line, when you have an equation, right? Remember that? Like a base fit curve, equation. Okay. So let me put some notes here. All right. So note, because this is measured measured data means like the temperatures are measured data, right? We are representing it on the plot as point. We only use continuous lines for theoretical plots. So something we calculated based on an equation. Okay. Now you can put some more thing here like the x limit, y limit. You guys remember the x limit, y limit, x lim, y lim, those functions that we learned? You guys remember the x level, y level as well, right? So let's do some of these things here. So say like your x limit. The reason you're doing the x limit, remember, in a year there are like only 12 months, so you don't actually have to put more of them, right? So basically, before you do the x limit, let me show you how it was looking. Okay, so you do have it start from 0, right? There is no 0 month, so you may want to start from 1. So you'd like to specify the x limit from 1 to 12. Is it okay? Everyone understand? Okay, so you can avoid the confusion. So xlim, that's the function name, by the way. So anytime you have a function written, make sure you have a parenthesis, so to put the argument. Now the argument here is you have to define a matrix, right? So which has a 0 to 12, right? Sorry, 1 to 12. So you have this matrix always goes by this bracket, and then you have this 1 space 12. So that should do. And then you have this x level, right? So that's the function. On the x level, you have seen this thing last class. You want to put the time, and the unit is months, right? And then the y level, you'd like to put the temperature. So temperature, and the unit is Fahrenheit, so degree Fahrenheit. Now if you're going to put a 0 and power sign, it will gonna so not the power here, sorry, power here before the 0. If you have a power like power sign before the 0 is gonna be superscript. It makes sense. So it will gonna looks like a degree Fahrenheit. Okay, even though we are not displaying it, but just for understanding purpose for later, if it yeah, we're actually displaying it, I'm sorry. Later you're gonna need that. So you want to finish this bracket, and then you're going to put a title. So the title of this plot is average. So average, high and low temps for Canton, New York. You guys remember how to change the font size, right? For the title, X level, Y level. You just have to use the font size. So if you'd like to, like this case is too small, so just use the font size and change it to whatever size you'd like to see, and it should do. Did you see, like now it is in x-axis no longer 0? Okay, in x-axis it start from 1, so 1 2 3 4 everything. Any question? Everybody's done? Is it working for you? Should I move on? The second example. It's good, right? Second example. Yeah.
When you type in the parentheses, how do you get like the double-sided ones? Like where you just type in the middle. Like instead of just typing one parenthesis one. You know what I'm talking about?
Double-sided means.
Like when you type out a parenthesis, you get both, like the first and last one.
Yeah, yeah.
How do you get that?
Oh, yeah. There is this 9 and 0. Shift 9 and 0. So like here, Shift 9 we're gonna give the left one. Shift 0 is gonna give me the right one.
Oh, okay. And you just go back to the middle.
Yeah. Then I go back to the middle. Click on the middle in the cursor somewhere, and then do whatever. Any more questions? It's good. Are you ready for the example number 2? Okay. So we are dealing with example number 2. So this is what, like the plotting trajectories. What is trajectories means? So this one would be like the second order equation that you learn in physics class. All of you took physics 1, physics 2 here. Okay, did you learn the projectile motion equation? Okay, so like in a physics lab, like we had this. I know that in physics lab, in physics 1, we had this projectile motion lab, right? Remember, a projectile is running, right? Jason, you did the physics long ago, I know, long ago, right? Forgot everything. So you see the projectile. Let me explain, Jason, what happens. See, the projectile goes run, right? When it goes run from a certain point with an angle and velocity, initial velocity, right? So when it goes run in the up and fly, okay, if you're interested to find, like, at what location it ends, right? X and Y location, I'm saying in 2D, then this equation could be implemented here, right, in a projectile motion. So basically, you can calculate how far it can travel. You can calculate how long it takes, depending on other parameters that is known. Okay, in both in X and Y direction. Okay, so they have the equations over there. We'll be using those equations. Okay. All right, so we are doing the plotting, we are doing the projectile. Example number 1. So a little bit about the problem description. So problem statement. So someone kicks a soccer ball at 30 meter per second at an angle of 25 degrees above a horizontal line. Plot the trajectory of the ball. Okay, so you have the equation. So on those equations you have remember, Jason, I was talking about the location X and Y in 2D coordinates, right? So you need to know the equations before you use it here in the MATLAB or Octave code. So X location can be defined as X0 is the initial position, right? X0, I don't know, can be written this way, plus Vx0. Let me write this x0 as like this. So Vx0 multiplied by t. What does it mean? It means initial position x0. Vx0 means initial velocity in x location, right? In x direction. And the velocity of that ball, what happened? See, a football player kicked the ball. So when Yoshi kicked the ball, it does have an angle, right? So that angle 30 and the initial velocity is given. So the velocity, you see, where my feet is moving, it does have an angle, right? So if it is an angle, the initial velocity has both x component and the y component. So Vx0 is the x component. You understand? All right. And t is the time, right? So that's for the what? Like, after you kick the ball is gonna fly up on the air. After some time, say t, that time, whatever means and whatever. After some time, the ball will be either on the space or in the ground, right? Wherever it is, the x location distance you can find it by using this equation. Does it make sense? So I do have an equation for y as well. Let me give it to that. So the y equation would be so the y equation would be y equal y0, right, plus vy0 multiplied the t, and there's this third thing we're going to come, which is negative 0.5 multiplied g multiplied t squared. Now here's the thing. You see, the g is the gravity. The ball is running against the gravity, right? Gravity is trying to pull it down, so that's why you have a negative. Okay, so that's the equation for x and y location. Okay, and then I'd like to start with some of the givens, so which is like the time matrix. Start from 0 with the interval of 0.1, and it is up to 2.6 seconds, right? You don't like to display that, so put a semicolon, and then with the unit first to the second, right? This is the time matrix for plotting values. Now here, obviously, you understand the time starts from 0 to 2.6 seconds, right? And with the interval of 1 second means like every 1 second you'd like to display it in the plot. Is it clear? So as if like at 0 second, what is the y value or x value? At 0.1 second, what is the y value or x value? This goes up to at 2.6 second, what is the x value and y value? So you are defining a time matrix t, which has the element starting from 0 to 2.6 with interval of 0.1. Is it clear to everyone? Everyone understand? Ben, you understand the time? Okay, perfect. Ooh. Ethan, your computer problem solved? Those guys installed this? The plotting is working on that computer now?
No, it's not. Sorry. I've been doing the coding right. I've been putting it exactly how you do it. I just don't think they've gotten to it yet. That's all.
But they're gonna solve it, right?
Yeah.
The number?
Yeah. I think I wasn't able to give them the number, but I did. They did. I don't know. You were supposed to be in the email chain of. They said they were gonna check it this week.
So make sure you do that.
I will do that.
Yeah. So otherwise they're gonna get complaint and confused which copy they will from.
Yeah.
So this is the tag. Oh. Pretty sure. There is no other sticker, right? All right. Okay. So the time matrix got defined, obviously. Now you have two more matrices, which is the Vx0. Everybody remember the Vx0? What is that, right? The initial velocity, right? So Vx0, you are defining that with, remember, they give you the 30, right? The 30 meter per second. Now it does have two components, right? What are the components? X and Y components. So like cos d, you remember what is the difference between cos d and d? Sorry, what is the difference between cos d and cos? Degrees versus radians, right? Yes. So since the angles are given in degree, so we got to use this cos d function, and then you don't like to display it, obviously. You'd like to explain it though. You have the meter per second is the unit, right? So which is initial horizontal velocity. So then you have the y0 30 multiplied sine d 25, and this one would be meter per second. This one would be initial vertical velocity. Okay, and then you would like to define the G, which is 9.81, and the unit would be meter per second square, right? Because that's the acceleration unit. So this would be your acceleration due to gravity. Okay, and then your x0 is your initial location in the coordinate system. Assume it's 0. Okay, with the unit of what, like meter, right? And you can write this thing is initial location of the ball, right? Then your y0 equals 0, and you can put the unit as like meter. You can write initial location of the ball y axis value, and the top one is x axis value, right? So x0 and y0 is done. So I'd like to put some notes in the homework that you are doing. You got to actually solve the time. So when you are doing the homework, here we're given with the time, right? In the homework you have to solve the time, so it's a little different. Just want to give you that highlight. So when you're doing the homework, must solve for the time the ball hits the ground using the equation y equal vy 0 multiplied t minus 0.5 multiplied g multiplied t square. Now here's the thing. See, in the homework, right? If you know the distance of y, so then plug the value of the y, and depending and on the homework, if I remember correctly, so something, a projectile was falling from a running plane, right? So if the plane altitude is known, that's your y value. Make sense? So you plug the value of the y to find the value of the what, t unknown. Okay, so homework, you got to solve the t first, okay, and then with the t we're gonna use the other values. Now how will we solve the t? We need to know the y value. Is it clear? You understand? All right, so this is the notes for the homework or hints. So I'm gonna give some more. So consider rearranging the equation. So 0.5. So when you're rearranging the equation, minus 0.5 multiplied by g multiplied by t square plus VO y multiplied t minus y equals 0. So which is similar to a quadratic equation, right? Similar to what? Like, a x square plus bx plus c. Everybody remember that? A quadratic equation solution. Okay. So you gotta use the quadratic equation to solve for t, and this will be the final time. Okay, so now that this is just a note for your homework. Okay, you're gonna need it. So back to the problem. So use the T matrix to calculate all the x and y position, all the x and y positions of the ball based on time. So you have this x equal xo plus bxo multiplied t, and this is in meter. So this is your x locations of ball based on time, and then your y is equal to yo plus byo multiplied t minus 0.5 multiplied g multiplied t square. So here's the thing. You guys remember the t, is it a matrix? Time is a matrix, right? So you guys remember from last class, like, matrix class, if you'd like to do a power of a matrix, what are you going to do? You're going to put a period sign, a dot before the power. You remember that? If you don't put a period or the dot before the power sign, you may run it and you'll be seeing this is not running. When you remember that there is a dot. Jason, you remember there's a dot? If you have a matrix, right? Okay, I'm seeing you guys still typing. Finish your typing, then I'm gonna address that. I'm gonna stop myself here. Just want to make sure you guys are with me on this, what I'm saying. Ethan, you remember the dot thing for a matrix, right? So the time is a matrix, right? T. So if you like to square the time matrix, you just have to put a dot before the power sign, right? Ben, you remember that dot thing? Okay, let me know when you guys are done with the typing. I'm almost done. It's not too much. After this, we'll just simply draw this plot and then be done. Okay, let me know when you're done. Okay. Okay, and emphasizing on the dot again and again, okay? The dot is so important. If you don't do the dot, you're not going to run, okay? Okay, so then, obviously, I'm going to put some more info about here. What is that we're doing? We're finding the location, y location, right? So this is my y location, y locations of ball based on time. And then we would like to do the plot. So plot our solution. So what are the solutions? So you have, this thing needs to be in figure 2. Figure 1 was defined for temperature already. This time you want to do subplot. So on the subplot, you would like to define two plot, in 2 rows and 1 column. Say like you'd like to draw the bottom one first. So the location 2 on the subplot, and then you are plotting the value of x and y. You do have the x and y already, right? And then you'd like to put some more info like the x level, which would be horizontal, position, Then y level would be vertical position or height, either way. Unit is meter again. Okay, straightforward. And then you're gonna put a title. Make sure anytime you put a function name, all starts with small letter, right? Lowercase. You remember that, right? Okay, then the position of the ball. So there's the title. And then you'd like to do another plot. Remember, you had the subplot, and this time you have 2 comma 1 2 comma 2 comma 1. I think this one would be at position 1, top position that you're gonna plot. I changed the subplot to 2 comma 2 comma 1 comma 1 for the top one. Okay, so then I think I have it typed in my notes. So then you wanna do the plot. For the second plot, you wanna do x location only, and then you wanna put this x label. And then you wanna put the x label inside the time in second, right? Y level, you wanna put the horizontal position, right? Horizontal position in meter. And you're gonna put the title, horizontal position of the ball. Then you're gonna do the final subplot. This will be 2 comma 2 comma 2. Then you're gonna do the plot t comma y. The x level. Basically, in the first plot you have x and y plot. Second plot you have t and x plot. Third plot you have t and y plot. T means time, x means location of x, y means location of y. So you're gonna put this x label. Same thing. Time. Sorry. Second. Y level. You're gonna put the vertical position. Okay. With a unit meter. And title. Vertical position of ball. And save it. You're gonna save it. You're gonna run it. I have a syntax error at y location of the ball. Okay, because I didn't put a dot before. Remember, I did say I gotta put a dot before, right? Otherwise, it's not gonna run. Hopefully, that gets resolved. Oh, I had another mistake here. It should be 0, not O. I typed O. That is the reason. Okay, now it's working. Okay, so there is this problem here. It needs to be 2 here. Sorry. So the subplot, first one I did correct it. Seems like that one I wanted to plot it at the bottom. All right, so the first figure I'm taking it out because we did solve it already. I'm putting the whole thing here so everybody can see it, and it should be running similarly what the way I have here, and that's it. That's it from me today. So I just had 2 more exercise example problem here, right? And next class I'm going to start with a new topic. The midterm is coming soon. This is week 5. After week 6. After week 6. Where's your other figure? Test. Like this. You got to type the code. Type the code, and there are some multiple choice questions. On paper, or you can also type it in multiple choice questions. I'm not saying in English. Try it in one. Second one is missing. Most likely you have.
Oh, I spelled label wrong.
Save it. No, I don't think it's the issue of the save. Probably there's another issue. Or the second one, while I two comma one. Same problem. Save it. Read them before you run, save it. Yeah. Now it's solved. And it's solved for everyone, right? That means you guys are done. You guys have any question? Anyone? Anybody have any question? Jason, you good? You understand everything? Confident to go and plot now? Sure? When you can deal with any plot now? Confident? Yeah. Everyone is confident now, right? Perfect. All right, so I'll see you guys again on Wednesday. Okay, till then, have a good day. So I'm gonna put it on Brightspace, the recording I'm talking.